Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll solve a trigonometry word problem. As per the problem, an observer 2 kilometers from the launching pad observes a vertically ascending rocket at an angle of elevation of 21 degrees. 5 seconds later, its angle of elevation increases to 35 degrees. In part A, we have to find how far did the rocket travel during the 5-second interval. The first step is to draw a diagram for this problem. Let's assume the observer is at point O, the launching pad is at point L, 2 kilometers away from the observer. The observer observes the rocket at an angle of elevation of 21 degrees. Let's assume the rocket is at point A because the rocket is going vertically in the upward direction. So this angle here is equal to 21 degrees. After 5 seconds, the angle of elevation of the rocket increases to 35 degrees. Let's assume the rocket is at point B after 5 seconds. So the measure of this angle is equal to 35 degrees. We have to find how far did the rocket travel during the 5-second interval. So we have to find the distance from A to B. We can find the distance from A to B by finding the distance from L to A and then L to B and then subtracting those distances. So distance from A to B will be equal to LB minus LA. Next, we can find the distance from L to A by analyzing triangle OLA. This is a right angle triangle. We are given the measure of angle O 21 degrees, and for the 21 degree angle, side AL represents the opposite side and side OL represents the adjacent side. So we can use the tan ratio to find the length of side LA. The formula for tan ratio is opposite over adjacent. The length of the adjacent side is 2 kilometers. We can isolate LA in this equation by cross multiplying 2 to the left side of the equation. Two times tan 21 degrees is equal to almost 0.77 and the unit is kilometers. So the length of side LA is 0.77 kilometers. Next, we should analyze triangle OLB to find the measure of side LB. We know the measure of angle O in this triangle. We want to find the length of side LB, which is the opposite side. We are given the length of side OL, which is the adjacent side. So we can use tan ratio. Next, we can cross multiply 2 to the left side of the equation. Two times tan 35 degrees is equal to 1.4 and the unit is kilometers. Therefore, the length of side LB is 1.4 kilometers. Now we can find the length of line segment AB. So AB is equal to 1.4 minus 0.77, which is equal to 0.63, and the unit is kilometers. This is the distance the rocket traveled during the 5-second interval. This should be the final answer for part A. Now we can answer part B. What is its average speed during the 5-second interval? For part B, we should use the formula for average speed. The formula for average speed is speed equals distance over time. During those 5 seconds, the rocket traveled from A to B, which is equal to 0.63 kilometers, and the time is 5 seconds. 0.63 divided by 5 is equal to 0.126, and the unit is kilometers per second. This is the average speed of the rocket during the 5-second interval. This should be the final answer for part B. Now we can answer part C. If it keeps going up at the same average speed, what will be its angle of elevation 15 seconds after the first sighting? The first sighting of the rocket happened at point A. For part C, we should draw a new diagram. That's the observer, that's the launching pad, and that's point A. The distance from L to A is 0.77 kilometers. Let's assume the rocket is at point C 15 seconds after the first sighting. We have to find the angle of elevation of point C. We have to find the measure of this angle theta. As per the problem, the rocket maintains the same average speed. So the first step is to find the distance from A to C using the distance formula. The formula is distance equals speed times time. The average speed of the rocket is 0.126 kilometers per second, and the time is 15 seconds. 0.126 times 15 is equal to 1.89, and the unit is kilometers. This is the distance from point A to point C. We can find the measure of angle theta, the angle of elevation of the rocket at point C, by analyzing triangle OLC. In this triangle, we know the length of side OL, which is 2 kilometers. The length of side LC is equal to 1.89 plus 0.77, which is equal to 2.66 kilometers. Side LC is opposite to angle theta, and side OL, which is 2 kilometers long, is the adjacent side. So we can use tan ratio to find the measure of angle theta. The formula for tan is opposite over adjacent. The length of the opposite side is 2.66 kilometers, and the length of the adjacent side is 2 kilometers. We can find the measure of angle theta by doing the inverse of tan. I got theta equals almost 53 degrees. This is the angle of elevation of the rocket 15 seconds after the first sighting. This should be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.